Pulmonary ventilation. So this is breathing. So inhalation and exhalation. Okay, so I'm going to do my little thoracic cavity, little trachea, bronchioles, and my big old alveoli. Okay, and here's the walls of my that. Bottom of my cavity is the diaphragm. Okay. Here's my alveoli. This is my trachea, remember. Okay. So in the alveoli, we have intrapulmonary pressure, which we called it. Intrapulmonary pressure. And inside the alveoli, the pressure, we'll say, is 0 millimeters of mercury. Okay, so and let me just go ahead and quit and quickly, before I forget, sorry, I forgot to put in the serous membrane here, so let me just put that in because that's kind of important. So you don't forget that it's there. Okay. All right, so we have intrapulmonary pressure, and the pressure in the alveoli we'll say is 0. Okay. Out here in the atmosphere, basically at sea level, atmospheric pressure is 760 millimeters per mercury. So we're just going to say that the pressure in the atmosphere is 0. Okay, like this is 1 atmosphere, so we're just going to call it 0. Okay, looking in our thoracic cavity, we have our intrapulmonary pressure in here. You have your intrapleural pressure here. And intrapleural pressure is always less than intrapulmonary pressure. Okay, so always less than alveolar pressure. Okay, so if the pressure in the alveoli is greater, that means that there's pressure here, the air there is hitting up against the wall, and since the pressure is less in here, alveoli stays inflated. Okay, it remains open. Okay, so that's how that stays open there, to allow air in. Okay, so when there is no movement of air, and this is where Boyle's law comes in. If there is no movement of air, then the pressure in the atmosphere equals the pressure in the alveoli. So 0, 0, no movement of air. Okay. All right, but air will move as you take a breath. So at the beginning of an inhale, the pressure in the alveolus, P alveoli, goes down. Okay, so how is this happening? Okay, so in order to begin an inhale, what do you have to do? Well, you have to contract the diaphragm. That starts your inhale, the contraction of the diaphragm. So the diaphragm, when it contracts, when it's relaxed, it looks like a dome. When it's contract, it goes down this way. And when it does that and it flattens out, it expands the thoracic cavity. Okay? So when that occurs, the volume of the thoracic cavity increases. So there's Boyle's law. The cavity is getting bigger, so the pressure's going down. Pressure's decreasing. Okay? So that's an inhale. So that means that the air is flowing in. Okay? So 3, air rushes in until the pressure in the alveoli equals 0. Because when the diaphragm went down and the air started coming in, the pressure was less than 0, was going down. Okay, so when this was going down, the pressure was less than 0 as the diaphragm contracts and air goes in. So it goes in until the pressure equalizes, and it's then 0 along with the atmospheric pressure. Since when the diaphragm went down and made the thoracic cavity bigger, it made the pressure go less than 0, which is less than 0 here in atmosphere, and that's why the air flowed in. Okay? All right, so 4. Once we inhale and the pressure gets equal again, 0 and 0, then you begin your exhale. So for like just not even a second, just a moment, there is no movement. There is no movement before you inhale, and when you get to the top of it and the pressure's equal again at 0, there is no movement. And then you exhale. So when you exhale, the diaphragm relaxes. So that means it goes back up to its dome shape. When that happens, the volume of the thoracic cavity decreases, goes down. When that happens, the pressure increases. Boyle's law. So now the pressure is greater than 0. So greater than atmospheric, and air rushes out. Until P alveoli equals P atmosphere, which is 0. Okay, so that is ventilation. And that's basically Boyle's law. So when you take a breath in, the air comes in because the diaphragm contracts and makes the thoracic cavity bigger, increases the volume, pressure goes down less than 0. Air rushes in. Equalizes to 0 again. You get that air stops moving for a moment. Pressure's equal, and then you exhale. Diaphragm relaxes, volume of the thoracic cavity decreases, and the pressure goes up and is greater than 0. Okay, and then that equalizes to 0 again as you finish your exhale, and then the whole thing happens again. And that is breathing. Okay, so there's that, and if there's anything else here. Like I said, the interpleural pressure, the pressure that's in here, is always less than alveolar pressure. If something happens, like you get stabbed in the chest, that pokes a hole in the serous membrane here, the serous cavity there, and air will go rush in here. And when that happens, then the pressure goes up, it goes above the alveolar pressure, and the lung will collapse. So the lung will collapse if air gets into the intrapleural space and the pressure is greater than intrapulmonary. Pressure, and that causes a collapsed lung. So I just wanted to make that distinction there.